This is my video presentation for task 8.1p for our bank account program. I'm just going to start by explaining briefly like the overall program, and we'll briefly go through the classes and also show what happens when we run the code. So we have a number of classes in our code: program, bank, account, transaction, deposit transaction, withdraw transaction, and transfer transaction. Our program class is sort of the main hub of the program. It takes in objects from all the other classes, and it takes in objects from all the other classes and displays the menu when we run our code. The bank class handles the lists of accounts that we create and the list of transactions that are made. The account class is for creating an account, and our account has fields of balance and name. The transaction class is an abstract class, and it serves as the parent class for deposit, withdraw, and transfer transactions. So it has properties and fields relating to the execution and reversal of transactions depending on if they run or not, and also can track when transactions occur. And then our deposit and withdraw transaction classes are quite similar. The deposit transaction and the withdraw transaction take in an account and an amount, and there's checks made to ensure that the deposit is more than zero, and the withdraw checks whether the balance is enough to be withdrawn, depending on the amount that is asked to be withdrawn. The transfer transaction class takes in two accounts and also a withdraw and a deposit object, and checks to make sure that those can both go through before executing the transfer transaction. So let's run the code and sort of see this in action. And we're presented with our 7 options: add account, deposit, withdraw, transfer, print transaction history, and quit. We'll start by adding an account. Into the account name we'll say M, into the balance we'll say 500. Now we'll start by testing a deposit. So we want to enter the account name and then the amount we wish to deposit, let's say 250. Now this transaction will be saved, and if we print transaction history, actually let's do a withdraw first maybe. Into the account name M, we'll say withdraw 250. That's the same amount, but anyway, print transaction history. And here we can see that 250 was deposit, then 250 was withdrawn. If we want to make a transfer, then we're going to have to make another account. So let's add another account. I'll just say J, and they'll have an opening balance. Well, we can test if we put a random string of characters. Our code has catch blocks to enable us to sort of catch these and ensure that a valid number is put in. So let's put a valid number in. We'll say 1,000. Now that we have that account, we can do a transfer. We'll say M and then J, and say we want to transfer $43. And if we go to the transaction history, we'll see that transfer there. The transfer was successful, 43 was withdrawn from M, and 43 was deposited into J. And also, if we now print J's balance, we'll see that it's 1,043. Now I want to go over the key principles of object-oriented programming in relation to our bank account code. So the first one I want to go through is encapsulation. So encapsulation can be thought of as information hiding, and we have where we have an object, and this is a capsule, and it contains fields and methods, but the implementation of this can remain hidden. And allowing accessibility, we can allow accessibility through accessors and getters and mutators and setters. So looking at our code, we can look at the account class where we have some fields here, the private balance field and the private name field. We don't want other classes or anyone outside this class to change the balance. We want the balance to only be handled by the account class. We also have the name private field, and we do have a property that allows us to access the name, but it's only a read-only property. So we don't want to change the name, but this property allows us to get access to it. And we also have the public method of print, which is also, I guess, sort of a read-only way that we can access the name and the balance. In terms of abstraction, this is sort of representing real-world entities and objects without sharing all their complexity. So this limits what other classes can access or need to know from within the class. And we can do this through access modifiers. So in terms of our code, go to the program class. And when we're doing the deposit transaction and running it, the program class will check if this deposit has succeeded, but it doesn't know, like, it's only retrieving a Boolean value. So if we go to the succeeded, we have a property here in the deposit transaction where we're returning this Boolean value, but the program doesn't know what is going on beyond that. It is only receiving a true or false Boolean. Inheritance. So inheritance sort of extends abstraction to support generalization and specialization in relation with sort of using parent and child classes and removing the redundancy of having a bunch of similar classes if there's some similar methods and properties between them. So child classes can inherit properties and methods from the parent, override methods from the parent class, and have its own properties and methods. And we see that in our code with the transaction classes, starting with the transaction class, which is an abstract class and serves as the parent for deposit, withdraw, and transfer, because transaction has some fields and methods that are all similar and that are all used by deposit, withdraw, and transfer, such as amount, executed, and reverse. And these are protected, so it allows the child and parent classes to only access these fields. We also have properties, but some of these are public, so they can be accessed by other classes. And we have these methods in the parent class that can be accessed and used by each of the child classes. And these child classes also can contain their own methods, but in this case, we have the same methods. And that sort of leads us to polymorphism. So polymorphism relates to different objects and methods being accessed through the same interface. And we're going to talk about the two types, which are static or compile time, which relates to a same name method having two methods that are of the same name, but they have different arguments. And this is also known as method overloading. And there's also dynamic or runtime polymorphism, where the method in the child and parent class has the same name and arguments, but has different implementation or behavior. And this is known as method overriding. So in the case of our code, we have examples of dynamic or runtime polymorphism. As mentioned before, in the transaction class, we have these methods, print, execute, and rollback. And these are overrided by these child classes. So looking at rollback, for example, this is the base code, which is called here. But then this is additional code. And for this to work, we also need the modifier override in the child class and virtual in the parent class. So rollback here calls the base rollback code of the parent class, this, and then adds this an additional code, which is executed, but just by the child.